Hi everyone, we are back with APIM Hotrod, and today I'm here with a new guest, with Mike Stevenson. Mike, how are you?
Yeah, I'm really good, thanks, Massimo. It's really good to see you, and looking forward to guesting on APIM Hotrod.
Wonderful. Actually, we even don't know if we call it APIM Hotrod, APIM Hotrod. It's free for
Oh,
everyone to
that
call it
sounds
the
like
way you want.
a poll for the subscribers to decide the best way to do it. I have a
Sounds a
feeling
great idea.
different countries probably have different ways that they would use it. If you remember back in like Windows workflow, it was always like if you were in America, it was dubf, and if you were in UK, it was um, WF or WCF, and then I think isn't it Scandinavia where it's double V or something like that.
Yeah, I was calling WCF, but yeah, it's
Yeah,
for everything. It's always funny to hear how the people pronounce it or how they see it
yeah,
in a different way for everything. Okay, today, Mike, we will talk about APIM and Terraform. Terraform for me is something that I don't use it a lot, or let's say I don't have experience. Let's say, in a, let's make it more strong. So I'm here to learn everything from you, APIM and Terraform. I see that you have over
yeah.
there a beautiful whiteboard. So, yeah, tell us.
Yes, we can pull that in if we need to explain some of the things. So I think for me, Massimo, I guess my current role is with Table 360 as the product owner, and I'm doing a lot of stuff in the space of kind of operations monitoring, cost management, and stuff, and still integration as well. But last year, when I was consulting, I'm working with customers delivering real world integration solutions, and this is really where we were using Terraform in Anger for our integration platform. Um, Terraform's actually something I got introduced to via a user group. Many years ago now, actually, one of the user groups where you go along and you discover somebody telling you about something you hadn't really come across before. And I was kind of thinking that's really cool. I like that. And at the time I started using Terraform, it was before anybody had really thought of Bicep. It wasn't really a thing, and ARM templates were really painful. People weren't really using them very effectively back a few years ago. And we needed to do infrastructure automation. And actually, the people who were doing infrastructure automation were using Terraform anyway. We tried to take what we could learn from that community and apply it to the integration community that we were building stuff for. Um, and for me, when we got in to start using Terraform, it wasn't just for API management, it was for the wider Azure Integration Services. And I think, that question of why should I use it? Well, one of the fundamental decisions for me was I need to do automation for not just API management, but building the PaaS resources I need for integration, configuring things like Service Bus, configuring other Azure resources. Um, but also we even would, we could even do it for things like logic app consumption at the time. Um, and for me, what I really wanted was that the challenge on Azure is there's so many different skill sets that I have to learn that getting everybody in the team skilled up on all of them is such a big challenge that if for me, Terraform was an abstraction that let me teach people one sort of coding / scripting language that would be common across the team as a standard. And then we could apply that to configure all of the different resource types. And it just took away some of those challenges where you would use one technology for one tool and a different technology for another. So that was one of the fundamental sort of things we wanted to do. And then as a team, if you think in your organization, we've got a team of, say, half a dozen people. They're building integration solutions across multiple projects at the same time. Each team member might be assigned to a project. They're going to build some logic apps, some service bus, some API management, and some functions probably. Um, Sometimes they need to build new components. Sometimes they would change components that already existed. So what we wanted to try and do was come up with like a cookie cutter approach or a standardization approach where I could have a developer builds components for one project, and they look as close as as similar as possible to the components a developer builds on another project, so that when I have these projects end, I can swap developers between projects, and they're not having to like relearn everything. It's like I pull you from project A, put you on project B. You should know how all the components get built, and it's only really the business functionality that changes. And for us to be able to have a small team at the time that could scale across all those projects, that was a really important underlying principle. And actually, one of the things that was really cool is when I was at, bear in mind we did this a few years ago, so you're probably talking like 2016 through, well, maybe not that far away. I think probably like 2019 through 2023, we were doing those kind of approaches. When I was at the Integrate Summit a few months ago, it was really interesting that every partner I'm speaking to, who are now, the last couple of years, they've been steadily increasing their amount of Azure iPaaS projects they're building, and all of them are developing approaches for being able to standardize, which shows that thing's so important to successfully deliver across multiple projects. Now the question is just really, which technology did you use to do it? Now for us at the time, we chose Terraform because it was really, pre-Bicep, it was the only real viable option. And also it just got the job done. It's if you're comfortable with it, you can solve most of the problems you need to do. There's a few hoops like any technology on the learning curve, but really it's just, I want to get on and be productive, and I want to minimize the number of hoops I've got to jump through to be productive. What we ended up doing, I'm going to jump on the whiteboard at this point, Massimo, just to show you a couple of things. So what we did, if you imagine, so I always used to describe this as being like a factory assembly line approach. So in my integration platform, sorry, I need my pen here. If you imagine in our DevOps, we had repos for the different types of solutions. So we'd have, like a logic app repo, function repo, and one of them would be an APIM repo, and we had other ones. And basically, if you imagine, if I'm Ford Motor Company building cars, what I would do is I'd build a plant and an assembly line that can build Ford Focus cars or Ford Sierra. I can't remember all the different models, but you build an assembly line for each type of car, and then you can build hundreds of those cars without too much effort. And what we wanted to do was take the same principle here. So for API management, I had a repo which we followed the mono repo pattern, where we had one folder for each component that we used for APIM. So really one folder for each API. And we had a template, and then what I would do is every new project, I'd clone the template. There's my new API. It follows a standard approach. And then we can clone a build pipeline. And then, within about, for me getting a new requirement for an API, within about 15 minutes to 20 minutes, I'm up and running with a new API that already has the template structure in place. It already has the entire DevOps pipeline experience in place, and I could actually deploy that to production straight away. And I've solved that entire DevOps problem. Now, what was happening before we did that was, for every component, developers would come along and they would go, right, we start building our custom component. API management's just one example, but it could have been the others as well. And they would spend, a couple of days, couple of weeks building features. They'd get to where they say, right, we're now dev complete. Then the next task they had to do was DevOps, in quotes. And what would happen is there would be at least maybe 2 days to a week assigned on the project plan for DevOps, which meant I could take the code from my machine and figure out how to reliably deploy it into any of the test environments to be able to get them to test it. And then once they had testing done, they would then have this DevOps task to try and get it into production. And what happened is those problems just don't, they waste loads of time. And we completely flipped it on its head with this approach, where I create from my template and I get it into production in like a couple of clicks in the first 20 minutes. And that means my entire DevOps process is up and running and they're all exactly the same as each other. And now I start working on the functionality. Now, after I've done that, I may have to tweak a couple of things like variables, but in general, none of the DevOps pipelines ever changed. They all were pretty much the same as the template. And developers can get on and just get stuff done, but we get rid of those two DevOps blocks of work later in the pipeline, which is where everybody ends up doing everything different. So what this really looked like is in APIM, we've got all these repos here. We then have our pipeline that would deploy out to, dev, test, and prod. And we could basically just deploy any APIM component, just follow that pattern really easily. And we just replicated that for all of the other component types. And one trade-off we had to make is we obviously had a lot of components that could be, so we had to manage from a sort of change management perspective, each new project, which components does it need to be changed? So, we still have some challenges to deal with, but all of the technical challenges pretty much went away. And we got to the point where all of the developers, not really any of them are DevOps experts, but we wanted them to do the DevOps tasks without needing a dedicated DevOps expert on the team. And that's really how we achieved that. Now, I'm going to take a step down from that level now. And
I have a little question here, Mike.
Yeah, go for it. Yeah.
Just tell me if I see if I get the point here. I see this is sort of third level of industrialization when you have the first level, like the platform landing zone, then there is the second level, the application landing zone, and this case is like the industrialization of the integration part in the context of application, right? So you fork and then you duplicate. You roll it out. The same approach for all of your integration. Is your integration framework at the end of the day?
Yeah, exactly. Yeah. So the key point is whatever technology you use as a company by company choice, the fact that you're having a standardized approach with a framework is where you'll get the benefits longer term, because you reduce the maintainability, because what you want to avoid is having every single thing you build is like, if you come back to that car analogy before, if I'm the garage who has to maintain these cars, if every car that ever gets produced by Ford's completely different, it's impossible for garages to maintain them.
Yeah, exactly.
But if every car's a Ford Focus or a Ford Sierra, then the garage just has to learn how to maintain two types of car, and they can do millions of cars. That's engineering principles kind of come into play, I guess.
Yeah, and other things that we mentioned a couple of times in APIM Hotrod when we were talking about APIs and API management in general. Most of the time we saw that at customers, those APIs that we deploy in API management, most of the time they are passed through sort of one-to-one with the backend.
Yeah.
So in your framework here that you're describing, you were facing the same scenario most of the time, or you were also making up the framework to build up, I don't know, compound API where you aggregate operation from different backends, something like this?
I think we can deal with different kinds, if I'm honest, in that scenario. It really, from this perspective, if the level we're at here, it doesn't really matter what the API does. If the next level down, when we start looking inside the individual API, that's where it can vary. But I think the framework here would allow you to be able to deal with those differences. And I can kind of bring up an example to show you that I think would be a good one to talk through. So if I'll just pull it. I'll put a little bit of code on the screen now, and I'll just kind of guide you through that. Okay, so if you just bear with me for a second. So I think if we pull this code on the screen here, right? So If you
Maybe if you
imagine,
can just do a control plus a couple or one of.
yeah, just there you go. Can you see that? Okay.
Yeah, it's okay. Thank you, Mike.
Yeah. So if you imagine in my repo, I have this template solution. From the template, I've now created a solution for an API that's going to do something, and I'm now going to then start as a developer building this API to do the feature that I want it to do. Now, in terms of the structure, we were doing a couple of things here. So first off, Terraform Solutions, a folder that's got .tf files inside it. So you'll notice some of these files have that .tf extension. And what happens is when I run Terraform, I've got a number of commands that I can do. So things like the validate command would go and look at all these .tf files and check that they're correct and that they sort of they would work and effectively would they compile. You then have the plan command, and what that would do is it would look at the configuration in Terraform for the resources you've defined to build, and it would go and compare that against what you've got deployed in Azure already and tell you about any differences. And then you can decide if you're happy with those differences and what things it would do. So for example, let's say if I had an API in the cloud that had one operation and my Terraform code has a second operation added to it, then Terraform plan would say, I can see you've added a new operation to the code. Would you like to go and add that operation in the cloud? And then if you apply it, it would go and make that change. It could also do things like it would say, oh, you've changed this operation. Would you like to go and change it in the cloud? Or one of the things I really like that I think's maybe a bit of a difference between Bicep and ARM is it can also say things like you've taken this operation out. Would you like to destroy this operation? Would you like to destroy this this entire API, for example? I think it's quite a good one. Now, in terms of what Terraform's doing, there's a couple of key things. If we do like a foundation piece, Massimo, on Terraform, there's a couple of key types of things in here. So the first one is you've got what's called a resource. So if I go and grab one of these here and just show you what that would look like. So here, what I'm doing in these files here, I've got code in them that'll describe what a resource looks like. So if you imagine here, I'm building an API with some operations. So here, you'd notice the resource keyword and the next section. So if you imagine on this line here, we've really got three key elements. The first one says this is a resource. The next one tells me this is what kind of resource it is. So it's saying this is an API management API. And the third one's really a key, so that if I have multiple APIs in this solution, I could give them a key, so I can reference them as a bit like referencing an object, for example. Now, with a resource, what I'm saying here is this is something I want to manage. So that means I can change it, add it, or delete it. And how that would work is Terraform doing a diff between what have you got deployed and what have you got in your code. So, and how it does the diff really, it has a state file that would be stored somewhere. You would refresh the state file from what you've got deployed, and then you would do a diff against the state file versus what your code says it should do, and then it would apply the changes. Now, in here with the API, it's very Bicep-like if somebody's familiar with that already. So I'm saying I've got a name for my API. It belongs to a resource group. It's got, it's got a path and that kind of thing. And you just define these here. But where things get quite cool is things like my resource group. I can say, right, well, if you notice here, I've got this data keyword. So in addition to a resource, there's another kind of object in Terraform called a data provider. And basically it's effectively a read-only thing. So I can point to a resource group, which I think, if I remember right, that should be in this bit of code here. So you see the data keyword, I've said I've got a resource group, and I can provide a variable at runtime to give it the name of the resource group. So what I'm going to do is say, create a pointer to the resource group, and then when you deploy my API, the resource group you're going to tell the API to deploy to will be whatever the name of this pointer you've got here. So what that means, if you notice here, I'm supplying a variable. So when I deploy to different environments, I can just change the name of the resource group as like a dynamic variable, so that I can run my pipeline for dev and say deploy it at the dev resource group, run it for test, and it'll deploy it to the dev one. And that kind of approach will be really common across Terraform. You know, in this case, in your APIM solution, for things like, let's say, you know, beyond just deploy it to a resource group, if I want to have an API that points to a logic app, so I could say deploy my API, but the back end for my API, I could configure that to read at runtime. When I do the deployment, it'll go and read the URL for the logic app, because I'll create a pointer to the logic app. I'll create a way for it to read the runtime URL, and then I'll just inject that into my API when I do the deployment. And again, we're kind of, you know, Terraform's providing that abstraction layer. So the fact that one of them is really a deployment activity and one of them's an API call against Azure to read the URL, that's kind of abstracted from the developer a little bit. They're just doing it all with Terraform.
While you, sorry if I interrupt you, Mike, while you were explaining this, something came to my mind. Have you it ever happened to you that by mistake, some developers, anybody involved in the development team, modified with two different pipelines the same object? So then when you run your Terraform and you check the state, you have a sort of false positive?
So you would actually get an error, I think, in that scenario, because so let's say if I deploy my API with pipeline number 1, right, and I successfully deploy it, that creates a new API. In pipeline number 2, if I accidentally point to the API deployed by pipeline 1, what would happen is it would say the API already exists, but it doesn't exist in the state file for Terraform for this solution. So it would say you either need to import it because it already exists, or you can't proceed. And that's actually maybe one of the benefits with Terraform, because I have a feeling in ARM/bicep it would just overwrite the API, because it doesn't really care that it's like a managed resource. You're just saying go and do this stuff to it. Whereas Terraform's a little bit more like I'm trying to think of the right word here, but like desired state configuration.
Yeah. So I in this case, I understood that the best practice is to have one state file per solution. That's what you would advise. Okay.
Yeah.
Okay. Thank you.
So really a solution state. Each Azure resource should be managed within one solution. And that's why if I have, so you'll see, for example, here, one of the other data resources I'm using is a key vault. So in this API, I might want to go and read keys or secrets from key vault and deploy them into this, into this API or something like that. But I don't want to manage the key vault in this solution, because I'm actually creating that. You know, if I build a new environment from scratch, I run my land and zone Terraform, that would create all my key vault and everything. But then this individual solution here for this API, I might create a secret in that key vault, and I might, use that secret within this API. But I'd be using the data pointer to say, rather than me hard coding the name of the key vault, I'll just go and look it up at runtime, kind of thing, from this resource. So if we go back to this API, so what this API example was doing is it's a proxy for Key Vault. So the reason we built this API, if you imagine in an integration platform, we typically have different types of APIs. So often we'll have APIs that we expose to applications outside of the integration platform so they can send data to us. We often have APIs that we use from inside the integration platform as a proxy to talk to external applications in the outside world. And we often have these utility APIs. So in this case, the utility API is so we can call Key Vault from a central place, but put caching on as well. So one of the examples here from our logic apps was we used the Key Vault connector quite a lot, and we found that under load it was quite slow looking up all the keys all the time. So we put APIM as a proxy with a cache on it, and we found it was quite a bit quicker, and it got rid of all of the from a logic app side. It was very easy for us to configure logic app to APIM, but I didn't want to have to create the cloud connector over and over again for logic apps, so it just simplified things a bit. But this API, if you imagine here, I'm building the API and setting the settings on it, and then the next thing I can do is put a policy. So this would be a policy for the API itself. And you can see I can just embed the XML down here for this individual API. So I think at the time that this example was from where we were doing an ICE migration. So we had a few complexities around whether consumption logic apps, ICE ones, could call this API. So we had to do a bit of magic in this policy, but I can just put the XML down here and it deploys. And then if we look up here, this was the operation. So this here is the operation where I call APIM and say get a secret that proxies to Key Vault, gets the secret, but it'll put caching on. So I can define my operation here. Line 10, I'm basically saying this operation belongs to this API. So that really references the other file. I define, so there's a template parameter here. So when you call the API, you just pass the secret name that you want. I can do, if I want to do some of the richer features, I can put examples in here and responses and all the things that you might do as you build your API up. But the key bit I kind of wanted to show you was the policy. So here for the above object where I create the operation, here I'm saying there's a policy, and you can see what I'm doing down here. This one's a URI rewrite, which would forward it onto the Key Vault. I need to specify the API version when I forward it on. You can see up here I've got the cache lookup if I want to implement that response cache, and I think down here, it's been a while since I looked at this one to remember exactly what it was doing, but I think we just formatted the data a little bit. I think we converted, if I remember right, we converted the response, so we only returned the value of the secret, so we didn't have to parse it in the logic apps, for example, and then we just cache it. And then we've got a bit of standard error handling down the bottom, and really that approach from a developer perspective, every time they build a new API, it was usually just create one of these files. The configuration's almost exactly the same, and the policy just changes a bit on any new operations for any APIs that you have. And I kind of, I'm getting the developers where they're not having to rethink every problem every time. How you build the API, how you build the operation is that standardized approach. And then it's just really what functionality do you need it to do that differs.
And in your integration solutions, you tend to, like this example of Key Vault utility, do you tend to proxy a lot of functionalities in API management? I don't know now. One is Key Vault, then you might have storage account. You might have so is a pattern that you repeat often?
Yeah, so there's two reasons we did that. I think that would jump out. So number one, that centralized monitoring and management of your resources, I think, is really handy. So, things like if I've got app insights, I can get a view of all of the different things using each API, and I can get a view of the performance of those. But also it comes to things like change management. So if in this case, maybe Key Vault's not the best example, but let's imagine I had a third-party application that I can call with a logic app connector, I can call it with an HTTP connector, or I can call it, let's pretend we've got a good example actually, say SAP as a real world one. So I can use the SAP connector. The SAP team expose a lot of their services with SOAP and REST, so I can call from logic apps through to that SAP with the HTTP connector directly, or I can go through API management to do it. Now, the big win for me would be if I go through API management, I can centralize the security, I can centralize the monitoring, and I can centralize the change management. So a good example would be if the SAP team change something. So for example, they change one of their credentials, I don't have to go and redeploy 30 logic apps that all get changed. I can only change one API management and everybody inherits that change automatically. And I think that's the big thing from an integration platform, that API management gives you a big accelerator for.
Yeah, so you decouple the management of your, let's say, integration workflow from the management of, or the life cycle of your external dependencies.
Yeah. And I'm not saying, I'm not saying don't use connectors. I'm just saying find the right balance. For me, SAP is a good one because we were strategically moving a lot towards web service-based SAP interactions. So, primarily we were trying to use that all data services where we can. If we couldn't do that, we'd use the SOAP services. And if we couldn't do that, we'd use the SAP connector. But the opposite will be true on things like Dataverse. If we have the Dataverse connector, if we can use that. Sorry, just a minute, Massimo. Sorry, I've been ill earlier this week and it was just catching up with me there. So with Dataverse, I think it's really interesting that I could do sort of web service interaction with Dataverse, but I think that the Dataverse connector gives you a lot more rich functionality, that it's really hard to craft the right messages in a direct web service to do it, where for me the Dataverse connector is like, it's a good choice out the box, but I do trade off that every logic app solution I need to configure that connector. But what we did do in those cases were, the hard thing with Dataverse, I need to manage the throttling capabilities, so I don't want to overload it and get 429 errors. So by default, we would use the Dataverse connector, but if we were going to be doing repeated lookups of the same data over and over again, there would have been cases where we chose to do API management instead of the connector, because things like if I want to look up an account, if I get hundreds of orders coming in, and a lot of them are going to be for the same accounts, if I can do a cache of that lookup and I say, here's the customer name, give me the customer ID, so when I create the order, I can link it correctly. That customer account lookup, if I can cache that in APIM, I take a lot of hits off Dataverse, which reduces my likelihood of getting a throttle and error. So I think that's a great case to use APIM instead of the connector. But I think you've got to make that on a you've got to have one standard approach, but then on a case-by-case basis, make sure there's like a non-functional reason to choose the second choice.
Okay, that's good. Thank you for this. So we are at the end of our episode, but I just have one more question, the classic one. When it's about Terraform, there is a classic question about OpenTofu, IBM, etc. These changes from let's say open source to, or the introduction of OpenTofu and IBM coming into the picture. Did this change anything to to your customer or to your approach?
Do you know, I'm not really sure if I've really noticed any changes for that, to be honest. I guess it's the same question of Microsoft buying GitHub. Does that really change anything? There's probably more noise than there is actual on the ground changes. Whether that'll change longer term or not, I'm not sure. But definitely one to watch. I think for me, the thing that I have noticed over the last couple of years, particularly, is Microsoft have done more sort of documentation to recognize that people do use Terraform, and they've put more samples and more, kind of like all the guidance nowadays usually has a Terraform, a bicep, an ARM, and an API version to it. And I think that recognizes that they treat it as maybe not the same as bicep, because Microsoft built bicep, but they treat it as a first class passenger in a way. But it'll be interesting to see if that does change longer term from that. So I guess watch this space would be my thought. I think the other thing to remember as well is for other clouds, outside of Azure, obviously nobody uses ARM or bicep because it's a Microsoft technology. So that transfer of people who, the DevOps team where people work on multi-cloud, Terraform has the benefits that I can build an AWS thing and an Azure thing in the same code base without needing a hugely different skill set. So,
But it's clear. I mean, what I saw that when there is a sort of multi-cloud, it's 100% Terraform, and it's never a discussion. When at least what I saw, I see. And the other case is like when people are fully into the Microsoft, the single cloud things, then Bicep, of course, AVM or whatever it is the first choice. But I mean, Terraform is still the most used approach for that kind of multi-technology or multi-cloud scenarios. Yeah.
Okay. I think it's the principles, the important bit, Massimo, aren't they? It's like, it's just a coding language. You can pick up a coding language really quickly. That's the easy bit for all of us to learn. It's the principles that underpin, regardless of whether you do Bicep, ARM, or Terraform, the principles about how you do it effectively are the bit that's the important thing, isn't it?
It's true, but also sometimes I heard the customer coming with a motivation like, I want to pick up the most used language, the language that has the biggest community, the language where I will have no problem to find developers, even if from a development point of view, I can say I can switch quickly from one to the other. But from enterprise point of view, the decision might be different, right? So the way.
Exactly. Yeah. Okay. Keeps us on our toes, mate, doesn't it? That's the good thing. It's exciting.
Yeah. Okay. So we are at the end of this episode. Mike, thank you so much for joining this show. Thank you so much for enlightening me with Terraform. And voila. So
thanks for having me, Massimo. All the best for the future episodes.
Thank you, Mike. And thank you, everyone who will watch this episode and follow us in this adventure.